So today we are going to learn how to develop an assay method for a formulation. Okay, now there are various methods to be doing this. Okay, so you have the first one that you have is a single point method. You have double point method. You have calibration curve method. You have chromatography method. In this chromatography method, you have HPLC, GC, various other chromatography methods. You have the specific absorbance method, wherein you use the formula of Beer-Lambert's law, which is A is equal to ABC. Right? These and various other methods as well. Not only these methods, but these are the various methods that you can use in order to develop an assay for a particular formulation. Now, it will depend on the formulation and the drug, which kind of a method you use. So today, we are going to be learning how to develop a method for calibration curve analysis. Okay, so let's say a question is given to us. We have a 2% weight by weight gel formulation of paracetamol. Okay, we have to develop an assay method for the same. Okay, so let's say we want to do it by calibration curve method. What we will do first is every single compound, for example, paracetamol, every single compound has a concentration range where the absorbance and the concentration graph is linear and proportional. Okay, so and mark my words, I say linear as well as proportional. Okay, because these two are different things altogether. Okay, what linear means is that upon increasing the concentration, the absorbance is increasing. Okay, so let's say what linear would mean is that if I have a concentration of 4 ppm, then my absorbance is, let's just imagine for any compound, if 4 ppm concentration is taken, we have an absorbance of 0.5. Okay, and if we have an 8 ppm solution of that same compound, you have an absorbance of 0.6. Okay, so this is linear because upon increasing the concentration, the absorbance increased, right? But is this proportional? The answer is no. This is not proportional. What proportional would mean is that let's say we have a 4 ppm solution and the absorbance that it has is 0.5. And if we take the 8 ppm solution of that same compound, the absorbance must be 1.0 because this has doubled. So this has to double if it is to be proportional. Okay, so that is the difference between linearity and proportionality. Now what we are saying here is that every single compound, like for example PCM here, has a concentration range where the absorbance and concentration, both of them are linear and proportional. Okay, so for PCM, the range is 2 to 10 ppm. Okay, now the concept of ppm I have already covered in one of my previous videos, and I've also covered how to convert a particular concentration term or concentration unit in terms of ppm. Okay, so this 2 to 10 ppm range, let's say this is the graph 2, 4, 6, 8 and 10. This is the concentration in terms of ppm. Then if the drug is paracetamol, this is the kind of graph we are going to expect. Okay, because as you can see here, as the concentration is increasing, the absorbance is increasing proportionately and it also has linearity. Okay, so this range 2 to 10 ppm, this is actually found out experimentally. Okay, so you take a paracetamol standard Okay, you make a stock solution. Stock solution is basically a solution of a known concentration. Stock solution. Okay, this stock solution you are going to dilute to various concentrations and plot graphs. Okay, so what you do is when you plot a graph, you are going to start with different concentrations. Okay, you don't know what that range is. Like here we already know the 2 to 10 ppm range. We don't know what that range is in cases of unknown samples. Here we know it's paracetamol, but let's say we are just developing a method and we don't know the linearity range of the drug. Okay, so what we do is keep diluting it. Let's say you try out 100 ppm, you try out 1000 ppm, in that range. So for 100 you would try out 80 to 120 ppm. For 1000 you would, let's say, try out 100 to 1200 ppm. Okay, so let's say you try out 80 to 120 ppm. So let's say this is 80, 90, 100, 110 and 120. Let's say you try this out. This is the absorbance, and let's say the graph that you are getting is this. Okay, this is the case in which linearity is observed, yes, definitely, but no proportionality observed. Okay, what does that mean? Is that if just like we discussed here, if the concentration is 90 ppm, let's say the absorbance right here is, let's say, 0.5. But if the concentration goes up to 100 ppm, this you can see that this is not proportional. This is not proportional. A proportionality line would be like this. It would be a straight line. Here we have a complete curve. So that means that it's not proportional even though it's linear. Okay, so you just try out all these different ranges and you finally arrive to a range where you can observe that the graph you're getting is linear and proportional. Just like in paracetamol, from 2 to 10, we have this kind of a graph. Okay, so you find that out first. Once you found that out, what you do is you take this gel, okay, and you convert it into a solution which has a concentration that lies within these limits. Okay, so you convert this entire gel, the 2% weight by weight gel that has been given to us, you convert it into a solution of concentration between 2 to 10. 2 to 10 ppm. Okay, this is what you do in order to just analyze the compound with calibration curve method. All right, so we'll also learn how to do this. First, you just have to find this range experimentally, 2 to 10 ppm linearity and proportionality range, and then convert this. Let's say, so we have a 2% weight by weight gel, right? Let's say this 2% weight by weight, what it means is that there is 2 grams of gel of the drug or paracetamol. This is the paracetamol inside of 100 grams of gel. Okay, this is the gel, which is the entire formulation, but ppm, which is 2 grams inside of 100 grams, is the paracetamol, which is the actual active ingredient inside. Okay, so this 2% weight by volume gel, let's say we take 1 gram of this. Okay, so we know that there is 2 grams in 100 grams. Then in 1 gram, how much can be there? So we just cross multiply this. This is pretty straightforward. 2 by 100, which gives you 0.02. Okay, so we take 1 gram of gel, which gives us 0.02 grams of the drug, which is paracetamol. Okay, now you also need to know the drug which you have, Since this is a gel, it is a solid formulation, okay? It's obviously semi-solid, but you weigh it. You don't measure it in a measuring cylinder, you weigh it on a weighing balance, which means that you have to take the weight, you have to consider the weight, okay? So, since that is the case, you can't take the absorbance of that thing unless it is in a solution form, okay? So, you need a solution form of the drug. You can't measure absorbance in solid and semi-solid states, okay? So you need, in this case, you need a solution form. So you take this 1 gram of gel, which contains 0.02 grams, 0.02 grams of paracetamol, and you dissolve it in NaOH, okay? Now, the important thing here is that if you have to dissolve it in some sort of a solvent, you have to know what it is soluble in, okay? So we already know that paracetamol is soluble in NaOH. So you just have to find that out experimentally as well. But in this case, we know already that it is soluble in NaOH and that its linearity range is in 2 to 10 ppm. Okay, so what you do is you dissolve in NaOH, 100 ml NaOH, okay? So what does this give you? The solution that you will get is 0.02 grams per 100 ml, right? You have 0.02 grams paracetamol and 100 ml NaOH. So it's pretty straightforward that you get this amount, this concentration of solution, okay? Now, this is where the ppm conversions come in handy, okay? Because you have this term and you have to convert it into ppm, because we know that the linearity range is in 2 to 10 ppm for this entire thing, right? For paracetamol. So what you have to do is you can just note down this is the concentration of the first term, C1, right? And you apply the formula C1V1 equals C2V2. Now we want, let's say we are trying to convert it into a concentration of 2 ppm. We choose this concentration for our gel, okay? So what we are going to do is we will consider 0.02 grams per 100 ml as C1. We don't know V1. We want to convert it into 2 ppm solution, which this entire conversion I've already covered in a previous video. So in case you guys don't understand this with this pace, then you can just watch that video. This is 2 ppm into V2. Let's say we want to convert it into 100 ml of 2 ppm solution. Okay, this term actually can be anything. The volumetric flasks that you get usually range from 10 ml, 20 ml, 25 ml, 50 ml, 100 ml, 200 ml, 250 ml. All of these volumetric flasks are an option. Let's say we are considering 100 ml here. So V2 we get as 100. Okay. So we just solve this entire thing. First we have to convert this into ppm, which will be 20 mg per 100 ml, which will be 20,000 micrograms per 100 ml. Just cancel this out and you have 20 ppm. Okay, so this entire term is actually equivalent to 20 ppm. So what you do is you just write down 20 into V1 is equal to 2 into 100. Now you get V1, 2 into 100 upon 20. Cancel this out, 10 ml. Okay. Actually, I apologize. Wait a minute. This is 200. 200. This will be 200 as well. So what you get here, this will be 1 ml, right? Now, as I've discussed this in the previous video where I did the ppm calculations, what this means is that you have to take 1 ml of this stock solution that you created, this 0.02 grams per 100 ml. You have to take 1 ml of 0.02 grams per 100 ml stock solution of paracetamol gel dissolved in NaOH, and what you do is you make it up to or rather I would use the term dilute to 100 ml, and this will result in a solution which is 2 ppm. Okay. Now here's where the magic happens. For the calibration curve example, you already have the calibration curve here, right? And this calibration curve is actually made from standard paracetamol solution, right? So you know that the concentration that you are getting here, as long as you've diluted it well enough, if you know that the concentration you're getting here is actually 2 ppm, and you will get a particular absorbance value for this, right? So let's say you get an absorbance value of 0.2 here. Okay. Now the thing is, this is the sample. Okay. So this is taken from the gel. This solution is formed from the gel. So you don't know if the gel is actually as pure as they are claiming it to be or not. That's why you're doing this assay method, right? So you need this 2 ppm to actually be 2 ppm. So what you do is you take this supposedly 2 ppm solution and you measure the absorbance of this. Okay. Let's say you measured the absorbance of this solution and it turned out to be 0.2. Okay. If this turned out to be 0.2, then as you can see here, the 2 ppm solution has an absorbance of 0.2 even for a standard paracetamol solution, right? So what that means is that this absorbance 0.2 is for 2 ppm, which means that this is 100% pure. Okay, which means obviously this usually isn't the case. It's not as easy. But let's say you ended up making a perfect formulation and you got the absorbance to be 0.2 exactly. That means that this complies with the claim. Okay, so the claim that it is a 2% weight by weight gel of paracetamol, it is actually true, right? But let's say you get the absorbance to be anything else than 0.2. Okay, let's say you get it 0.19, 0.21. These are the cases wherein there is tiny amounts of deviation, which means either you made an error while you were diluting the solutions in this entire assay method, or you made a mistake while formulating the solution. But this is still acceptable, usually. Okay, it just depends on how potent the drug is. But let's say you got an absorbance value of 0.4 or 0.5 or something ridiculous like that. What that means is that this gel that you have made, this is not actually 2% weight by weight gel. It is actually something else. You have either made a mistake during the dilution, which means that you have made a mistake during this entire process of assay, or you've made a mistake during the formulation itself. Okay, so this is how you can basically analyze a particular gel or any other formulation using calibration curve method by extrapolating the absorbance values. Okay, so that was the video. Thank you for watching.